this video, we're going to talk about a very interesting theorem in mathematics, and it's often called like one of the most beautiful theorems in mathematics. First, we'll look at all the components. So, its components look like they would never work together, but they come together in a very beautiful way. So, first, let's look at the number e. And e is, a lot of people who have taken math analysis or even algebra 2 understand what e is. If we draw, let's say, a coordinate plane, it's often called like the exponential function. And like all other exponential functions, it just it has a characteristic that looks like this. This is the equation y equals e to the x. But more importantly, it's used in finance, like continuous interest, where you find that amount equals principal e to the rate times time. And it comes out a lot in like economics, like here. It also comes out, it's the value of this limit. That's often how we define it. 1 plus 1 over x to the x. That's how e is defined. And it turns out to be a very important characteristic in mathematics, especially when we're doing like calculus, where we find that the derivative and integral of e to the x is e to the x, so it's a very interesting function. The next thing we'll look at is I, which is the imaginary number, which is defined as the square root of -1. And often, historically, mathematically, it's never had a use, because taking the square root of a negative number has never made any sense. But recently, when in physics and advanced math, it has gained a use. And often, it's plotted on the complex plane, where where it's real numbers versus imaginary numbers, I believe. And so something like I plus 1 would be plotted as 1, 1 at this point. And basically that's how I is. And then a lot of different applications have been done with it. And the last thing we're going to talk about is pi. And pi, a lot of you already know how useful pi is. If we just draw, let's say we draw a sphere. I'll just use this dish right here. Spheres are circles. It's very important, the spheres and circles. Let's just say we draw a circle right here, and the center will be around there somewhere. This is the radius. So basically, we know that the circumference equals 2 pi times the radius, and the diameter equals 2 times the radius. So circumference over diameter equals pi, and that's how it's defined, the ratio of the circumference to the diameter. And of course, it's been useful in things that don't even involve circles, like there's something called Buffin's needle, Buffin's needle, where you have a lined piece of paper, and let's say you just drop a bunch of needles on it. The proportion of needles that cross a line on that piece of paper has to do with pi. So, very interesting applications. And these three ideas in mathematics come together in this beautiful formula, which is called Euler's formula, or Euler's identity. And this is the statement. It says e raised to the power of I pi plus 1 equals 0. And a lot of people know about it and think it's awesome, but they don't really know how it's proved. So we'll go over some proofs of it, and we'll see how it's derived.